So we talked about what are arrays, we talked about what are vectors, we also talked about what are linked lists. Now, linked lists are also dynamic, they're also linear. A node in a linked list consists of some data value and a pointer to the next position. There are also various kinds of linked lists, singly linked lists, doubly linked lists, and so on. Uh, we also talked about stacks, the implementation of stacks using linked lists. Stacks follow LIFO principle, that is last in and first out. The insertion and deletion, that is push and pop, which takes place from the same position. So today we'll be talking about queues first, the remaining linear data structure. Now, imagine this real life scenario. You are going for a movie, so obviously you stand in a queue to book a ticket. Yeah, that is the first person to stand in the queue is the first one to get the service or to get the ticket. The same is true with the queues in data structures. The first element which is inserted in the queue data structure is the first one to get removed from the data structure. So the insertion of an element in queues is known as enqueue, and the deletion is known as dequeue. Now, what we basically do is we insert an element at the rare position, that is the last position of the queue data structure, and we remove the element, that is dequeue the element from the front position of the queue. So yeah, so what are queues? Queues are linear data structures. It is widely used, and as I said, it follows the FIFO principle, that is first in, first out. So that is exactly opposite to what we have seen in stacks. Stacks follow LIFO and queues follow FIFO. Moving towards the advantages, it removes the element without overhead and adds new element without overhead. Yeah, we have talked about what overhead is in our previous session. That is, we don't need to put up lots of efforts for such operations, simple tasks and simple manipulations in pointers and whatever you're using. If you are using arrays, so you just need to adjust the rear and front variable, and if you're using linked list for queues implementation, you just need to adjust the pointers. So you just need not worry much about it. And yeah, it is used to solve various real world problems. Now, disadvantages, again, it can't be used everywhere because as you can see that enqueuing and dequeuing takes place from some fixed positions. Yeah, so you cannot manipulate some random element over there. So yeah, it can't be used everywhere. Again, element existence check is linear. We also saw this thing in stacks. That is, we want to check the existence of an element. You cannot randomly do it. You need to traverse the entire queue and then check for its existence. And so the time complexity for that will be linear. And again, it is less flexible to execute for the very same reason that enqueuing and dequeuing takes place from some fixed position. So yeah, so it is not quite flexible to use. Uh, Now we will be discussing about the array implementation of queues. Previously, we have talked about the linked list implementation of stacks, but now we'll be talking about the array implementation of queues. So the major two operations which we see in queues is enqueue and dequeue. Enqueuing means addition or insertion of an element, and dequeuing means removing of an element. Now, when we suppose we consider an array, so when we enter an element, we first enter an element at the zeroth position. Then when we again enter an element, we enter that in the first position, then the second position, then the third position, and so on. So the element at the zeroth index is the first element to be inserted in the queue. So we will, so when we dequeue, so when we perform the dequeue operation, we will dequeue that value, that index. So as we have written over here, dequeue means removing from the front. Front matlab zeroth index. Enqueue matlab adding to the back. That is the rare position. That is the end of the array or the end of the linked list, whatever you feel comfortable with. Now, first of all, I have this thing in the enqueue. I have taken int val. That is, I have taken the value from the user, which is then passed to this enqueue function as a parameter. First of all, I'll check if rare is equal to size minus 1. That is, first of all, what we do is we initialize front and rare to minus 1. Yeah, because we initially we don't have a queue. We are uh, creating a new data structure, that is queue. So initially we set front and rear to -1, that is the index of the front element and the index of the rear element to be -1 since we don't have a key for now. Then we also have this size thing. Yeah, so what basically size is now, you can take the size from the user and proceed with that, or you can just take it as per your wish. So we'll first check if size is real equal to size -1. That is, if the size is 10, that is your queue can hold only 10 elements. If rear is equal to size -1, now rear, what is rear? Rear is the index of the last element. So if it is equal to the size -1, that is, it is the last index of the queue of the array which you have taken to be a queue. So we'll simply say queue is full, right? Because your size is 10 and we have already reached ninth position. So we cannot insert more elements. So yeah, we say queue is full. Else, if this condition is false, that is, rear is not equal to size -1, what we basically say is if front is equal to -1, that is, for now we don't have a queue, or we don't have a defined front element. What we basically do is front equal to 0. That is, now we have proceeded from -1 to 0. So now we have a front element, and that front element is going to be on 0th index for obvious reasons, because arrays are 0 based, and the 0th element of the array is going to be the first element of the queue. So we say front equal to 0. Front holds the index of the front element. Then we also say rear plus plus. That is, basically what we are doing. Initially it was -1, so we are incrementing that. So that will again be 0. So suppose our queue is completely empty. Yeah. So and also we have this thing inserted in an element, the first element of the queue. So the front will be also at the 0th index, and the rear will be also at 0th index, right? So yeah, so we increment this rear, and then we say items rear. Items is basically the name of the array which will act as a queue data structure in our case. So the at rear position, that is at the 0th index in our case currently, we'll hold this value which is passed to this function, enqueue function, and then we'll print inserted this value. Now suppose this thing is not true, that is front is not equal to -1, that is we already have a queue and we want to insert an element. Now insertion, as we said, if we enqueue an element at the back, so we don't do anything to this because we already have a key, we already have a front element, and front element is always at the 0th index. So the only thing we do is rear plus plus. So because if we have 3 elements in our queue currently and we want to insert an element, we will insert at the back. So 3 elements, matlab 0, 1 and 2 index are full. Now we want to insert an element at the 3rd index. Currently rear would be 2 because that is the rear element. But then we increment rear to be 3, and then we say items rear equal to 3, items rear equal to value. That is, the 3rd index will contain this value which is passed to this function, and then we say inserted value. Now moving on to the dequeue function. Dequeue is basically removing from the front. So first of all, we check that if front is equal to -1, that is, we don't even have a queue. So we say the queue is empty. So you definitely cannot remove an element. Else, if that condition is not true, that is, we already have a queue. So we have this front which consists of the index of the front element, that is obviously going to be 0. Then we say we print this value, that is, which we are going to delete, that is items front. Then what we say is front plus plus. Why? Because we are deleting the 0th element, so we don't want the 0th element in our queue. So we increment front plus plus. That is, now in our case, the front element will be at index 1. Why? Because we don't want the 0th element. We are dequeuing the 0th element, the 0th index of the array. So we do front plus plus. Then finally we check if front is greater than rear. Then we say front equal to rear equal to -1. Now why we do this? Suppose you have an array of size 7 which will be acting as a queue. So you have inserted 7 elements already from index 0 to 6. Now you keep on dequeuing stuff DQ the zeroth element, then front will be 1. Then you DQ the first element, then front will be 2, and so on. Now imagine the situation that you reach the sixth index. Now you only have an element at the sixth index. Front will be 6, rear will be 6. Now you also want to DQ that element as well. So now you DQ that thing, and you see it is front plus plus. Now what you get is the front will be equal to 7 and rear will be equal to 6, which is kind of absurd, yeah, because front cannot be greater than rear. So what we basically do is we say front equal to rear equal to -1, because obviously in this situation you have no elements in your queue because you have also DQ'd the last element. So at the end we say front equal to rear equal to -1 if front is greater than rear. So yeah, these are the two basic operations, NQ and DQ. Now we have different types of queues. We have simple linear queues, which we have seen right now. Then we also have circular queues where the front element is also connected to the capacity of the array which will hold your queues. For example, you have this 10 element array. So that 10 element, after the 10th element is DQ'd, we again insert it to the 0th element, or uh, we want to insert another element after the 10th element, we insert it at the front position, that is the 0th position. So this is basically the fundamentals of circular queues. Then we also have double-ended queues that in this case, as the name suggests, the insertion and deletion operation can take place from both the ends, that is from the front end and the rear end. So this is basically what double-ended queues are. Then finally, we have these priority queues. Now, priority queues are nothing but in a queue when elements are arranged when we DQ an element according to some priority. That is basically priority key, as it is seen in the diagram. The NQing takes place as it is, but the DQing of the element takes place from the element which is of the top priority. Yeah, so this is the decreasing priority order. The element with the top priority is the one which will be DQ'd first. So this is basically not the FIFO principle which we have currently seen. This is basically you remove an element which is given some top priority. That is the one which will get DQ'd, and not the first element which is inserted in the queue. And you decide the priority according to your needs. Maybe you want to arrange the elements in the ascending order, descending order. You want the highest valued element to be of the top priority, or the lowest valued element to be of the top priority. That is all up to you, and depending upon the problem which you get to solve with the queue data structures. So coming over to the applications now. Queues are used to implement BFS, that is breadth first search in graphs. That is one algorithm to traverse the graph. Then it is also used in networking printers. You might have seen this stuff when you have too many requests to a printer. That is, you want to print some sheets, and lots of computers are there in the room, and they all want to print something from the same printer. So the first one to send the request to print something will be basically the first one to get printed. Yeah. So it is also then used in queuing messages, input output operations. Yeah. So the input request, that is, if you ask something, if you ask a computer to perform some operations and you need some output. So that will definitely not be the case that if you ask something in order. Suppose you have this addition, subtraction, multiplication, division. You have asked all these three in order, like first multiplication, then division, then addition, then subtraction. You won't get the result of the division operation first, obviously. You'll get the answer for the multiplication first, because that is what we have asked the computer to compute first. So yeah, that is what happens. Then in industrial applications, it is used in traffic systems. That traffic lights, you might have seen that they are given some timer that it will switch on after some point of time, then it will switch on after some point of time. So these signals are basically arranged in queues. Yeah. So first of all, the left one will give a green signal for vehicles to move, then the right one, then the front one, then the back one. So that system is all arranged in a queue, so the order won't change. Otherwise, you can understand how fatal it would be. Then it is also used in asynchronous data transfer. Now, have, if you are familiar with asynchronous tasks, asynchronous JavaScript or something like that, you might know what this async means. That is basically you send some request over a server to get some response, to get some data or something like that. So if you have a series of requests, then you won't get the third request, the response for the third request first. Yes, so you will get the response for the first request first. Although it gets processed, for example, the second request may get processed faster than the first request. But when you want to get those responses and then do some tasks over it, so the first one will always get your response initially. So this is how asynchronous transfer. So yeah, asynchronous data transfer works according to this queue principle.